Good morning to all. This is A. Shakira Parvin. I am working as an assistant professor in the Department of Electronics and Communication Engineering in SNS College of Technology. So now let me see about a topic, propagation of light, under the subject optical and microwave engineering under the unit optical communication. So let me see. So ray theory transmission. So in optical communication, right? So we should know how the ray is propagating, right? So that should be understood according to the ray theory transmission, right? So if we know what is the concept behind the ray theory, then you can able to understand how the ray is propagated in the optical fibers. That is the main concept, okay? Right. So in ray theory transmission, we should concentrate on four features. The first one is total internal reflection. Second one is skew rays. Third one is acceptance angle, and the last one is the numerical aperture. Right. So let me see one by one in design thinking manner too. So design thinking is having 5 phases: empathize, define, ideate, prototype, and testing. Let me see one by one. Right. So first is about total internal reflection. Right. So what does it mean? So the ray, what we are going to pass on through the medium, it should be reflected, right? So that is total internal reflection. Refraction means it should be passed over to the next medium. It should not be reflected, it is passed on. That is said to be refracted, right? So here we are using Snell's law. So we all know Snell's law, I think so. So N1 sine pi 1 is equal to N2 sine pi 2. So N1 by N2 is equal to sine pi 2 by sine pi 1. So that is the basic logic behind this types of refraction. Right. So see these diagrams. So first is about the refraction and the limiting case of refraction and then reflection, right? So first when the ray is incident on a medium, right? So where it gets refracted, right? But some part of partial amount of ray will be getting refracted. So it is partial internal reflection, right? So while seeing the next diagram, limiting case of refraction. When the ray you passed on falls on to the 90° of the medium, then the ray will be refracted, right? So that is the critical angle pi c. So the angle where we pass is said to be the critical angle. So next is about the total internal reflection. So the ray which we passed on to the medium will get totally internally reflected, right? So that is the total internal reflection. So here the condition should be pi should be greater than pi c. See, the first angle is denoted as pi c, critical angle. The ray which reflected back to the medium will be always greater angle when compared to the critical angle. Pi should be greater than pi c. Keep it in mind. That is the concept of total internal reflection. Okay. So next is about the critical angle. So already I have told you sine pi 2 by pi 1 pi 1 by pi 2 is equal to n2 by n1. So that angle pi 2 by pi 1 is said to be the critical angle. So sine pi c is equal to n2 by n1, right? So here the critical angle term is very important. So in exam point of view, you will be asking about what is critical angle, what is the value of critical angle. Likewise, they will ask. And this is the propagation. So when the light when the total internal reflection happens, it will be moved on like as the propagation happens in the optical fiber. So this is the way or the ray is said to be the meridional rays. So how the ray is propagating in the optical fiber is shown in this diagram. And so the first one is total internal reflection, I have told you, and next is about the acceptance angle. So acceptance angle means the angle at which the ray should be propagated in the optical fiber. So here the ray should be propagated only in the core part, not in the cladding part, right? So when you choose the angle, the ray should be concentrate on the core part, not in the cladding part. Likewise, you have to choose the angle. So that angle is said to be the acceptance angle, right? So that is to be explained in very simple words. So if the ray is propagated in the cladding point, then it will be lost by radiation, right? So if the ray is passed on through the core only, it will be getting passed on in the optical fibers, right? The ray which is passing in the or which is settling down in the cladding part will be get radiated, right? So that is the concept of acceptance angle. and numerical aperture. So numerical aperture is the light collecting efficiency of the fiber, and it is the measure of the amount of light rays that can be accepted by the fiber. So that is said to be the sign of acceptance. So Na is equal to root of n1 square minus n2 square, otherwise n1 root of 2 del. If the value of n1 and n2 is given, you have to find first formula, or if the value of del, that is refractive index, the refractive index difference is given, then you have to calculate Na as to be n1 root of 2 del, right? So here n1 n naught sine pi naught is also, so acceptance angle theta a is sine inverse of Na. So if theta a is asked, if the Na is given, then you have to use that formula. Theta a is sine inverse of Na, numerical aperture, right? So this is the summary. So skew rays is the rays where it depends on the number of reflections, right? So all the four parameters are very important in terms of ray theory transmission in optical communication. So hope you all understand about the concept behind the ray theory transmission. So thank you for watching. Thank you.